neighboring polygons so that we can provide a blend. So we can go from a light to a dark or dark to a light. So it's not all flat is an even shading. This one here is uneven. Instead, it's gathered in a general, or what do you call it, a gradual transition from a dark to a light or light to a dark, which adds a little bit more realistic shading to the scene. So what is the neighboring average normal? Well, that's a good question. It depends on the calculation that you're providing. So the average of the surface normals of all triangles that share this vertex. So you take the surface normals, you average it out, and you can shade to a certain point and then contrast it. So if the triangle model is approximating an analytical surface, then normals could be computed directly from the surface descriptions. And did this with the sphere example and the lighting model. Actually, we saw that in a previous last time, actually. So we have a bilinear interpopulation that is used to shade the pixels of 3 vertex colors. Interpopulating happens in 2D versus 3D. So the advantage of this shading over the flat shading is that an underlying polygon structure can't be seen. In the flat shading, you can see the underlying polygon structure, which means you can see the vertexes, and you can see the lines in between the polygons. With this type of shading, I call it, for lack of a better word, I usually say it's smooth or it's blended. Well, that's what you're using here. So the OpenGL is going to use the word smooth actually to describe it, which means you can't see the transition between the different polygons, but they're going to be transitioned from a lighter to a darker. So there's going to be more blending. So here we would use a GL shade model, GL smooth, as a modeling approach to smooth the shading between the polygons. And here's an example here where we see it's a little bit lighter here and then it goes darker. You probably can't, if you download the slide set, you can probably see a little bit better. The screen doesn't do a good job with contrast, but it's gradually going darker to the point where you actually, I can still see it, but you probably can't see the part that's down here that's black actually. So the problem with ground shading is that specular highlights don't interpopulate correctly, which is an interesting phenomena that occurs here, which means we got a little spotlight here, but we're not going to be able to see other types of lights that might actually populate. It's not going to interpopulate as we'd see it. So if the object isn't constructed with enough triangles, you have artifacts that can be seen. Quick drop-offs, actually. So most of it might not necessarily render correctly, depending upon what we're looking at.